Welcome into Eye.Talk.Tech, where we explore the intersection of eye care and technology. Today, we are going to dive into a topic that's generating a lot of buzz, and that is virtual reality perimetry. And a new systemic review has just been published. It cuts through the marketing to give us some clear evidence-based looks at the clinical validity of these devices. And to discuss all that, joining us today here is Dr. Eric Schmidt, who has been following this technology closely. He's here to translate some of this dense scientific data into practical takeaways for the clinic. Dr. Schmidt, first of all, thanks for joining us today. How are you doing?
I'm doing great. Thanks for having me. This is a really great opportunity to be here.
Well, we're excited to have you. And before we dive into the systemic review, can you introduce yourself and just walk us through a little bit of your experience with VR headsets and optometry?
Yeah, sure. My name is Eric Schmidt. I'm the president of Omni Eye Specialists located in Wilmington, North Carolina. I'm the immediate past president of the Optometric Glaucoma Society, and I wear another hat as the assistant chief medical officer for Kepler Vision. So, with all those different hats I wear, I've had the in the glaucoma world, the visual fields devices have been near and dear to my heart for many, many years. My own private practice, when I see patients, I see strictly glaucoma 100% of the time. And, we've been stuck with these. I don't want to say stuck. We have had these devices, these visual field perimeter bowls since I was a resident back in the 90s, and they're great. They have some limitations, and but they're, in my opinion, I think we can probably do a little bit better on a few fronts on that. And so I started looking at the virtual reality visual field headsets as or devices a few years ago, because there was a big to do about it. And I really want to be able to tell doctors and my staff and my doctors whether or not they're ready for prime time or not, whether they're going to surpass or supplant what we have now. And so I've been looking at this for a long time, and then this article, this journal review that came across that we're going to talk about today, really added a lot of great perspective to my journey in this on this virtual reality path.
Well, I think that sets the stage wonderfully. So let's start with that review. Can you walk us through what sort of was conducted throughout this review and what the methodology was for in the study they looked at the
Yeah,
VR headsets here?
Dr. Christians, you mentioned that it's a systematic review, and that basically just means we have no other way to review these devices. So what the authors of this article did, and by the way, the two of them are optometrists, as authors in this journal. They kind of asked the question, well, can we compare these different virtual reality devices? Can we compare? Can somehow we get an apples to apples comparison on these devices, basically? And it's hard to do it because none of these have been studied head to head against each other. I'll use some companies. Hero's never been compared to the Radius XR device, right?
Sure.
The visual has never been compared to all eyes, and I don't think we're going to see that. So somehow you have to use statistics to kind of figure out, are they equal to each other, or does one do better in one stage of the disease and does another do better for a different type of metric that we're looking for? So to do that, you have to use a systematic review. So you look at studies that are all comparing the same thing. So every one of these studies compared a virtual reality device to a Humphrey Visual Field Analyzer. So, and I think that's important to know. So that's the level playing field.
Sure.
So with knowing that, then how do we compare a Hero device to a Radius XR device to an all eyes device? Well, you have to use matching statistics, basically, and that's where this article comes in handy. Now, before we do that, though, before you know the article, the authors looked at they basically looked at all the journal articles published for virtual reality visual field devices. There was 3,000 of them or something like that, and so they narrowed down their search to a very clinically relevant type of review. All of the devices that they looked at, all the studies had to be studied with devices that were FDA approved or FDA authorized. So we could buy, if I wanted to buy one of these devices today, I could do it. And that's important. So it's looking at stuff we have that's approved in the US. Secondly, they all had to be compared to the HFA, which is important. They all had to be original studies, so they couldn't be redone studies or repurposed studies. They all had to be independent studies. So these weren't all done by the companies that make the devices. They were done by independent studies, and again, they all had to be commercially available to us. And I think that's really super important that we do that.
So we had a significant degree of rigor,
We
certainly.
did, yes, sir. And with that rigor, these 3,000 studies boiled down to 17 studies. And so there was some of the
That
companies
met their criteria there?
that met that criteria. Yes, sir. And so that makes it much more manageable. You can't possibly fare through 3,000 papers to figure out the validity. But when you're down to 17, that gives a dense enough database where you can actually make a clinically valid decision on this. So that was kind of the part of it. The big part of it, that's the how. The the real challenge in this, and the reason why they had to use a systematic review, as you said, is you can't really compare these devices head to head because, first of all, the companies will never do that. It's hard to do. Secondly, there's different the devices are all different. There's differences in hardware, there's different in software, there's different algorithms that they use, there's different in the headset power, the headset design, the way the visual fields are actually projected to the patients are different. And there's different dynamic ranges, so that makes it again hard to have a head-to-head comparison. So
Sure.
because of that, the long way to go is you have to look at studies that have all similar metrics. They've looked at similar ways to measure the validity of the devices, and then you take the one statistic from study A and compare it to study B, compared to study C. As long as you're using the same statistics, it allows us to level the playing field and allows us to make a better decision, right? So
Yeah, I think that's important to highlight, right? So it's true that we're comparing apples to oranges, but we can utilize the statistics to say, hey, what can we learn from these apples and oranges, so to speak?
yeah, and at the end of the day, with and we have to have the ability as doctors to make a decision whether these devices or this device I'm looking at is as good as what I'm currently using. And why would I switch? Because the Humphrey Visual Field Analyzer has been used for years and years and years, right? And we're all comfortable with that. So if we're thinking about switching, let's not switch to something that's inferior, right? Something that's at least as good as what we have. And so this, by using these metrics, and some of them are quite complicated, but by using those, we can actually make a valid clinical decision for us.
Sure. Well, and I think a big portion of this study, in terms of learning what we can take away and utilize clinically, are the comparison tables associated with this study. So that's something maybe in post-production we can put up on the screen here. And so for our listeners, when they look at that table, what do they want to glean from that? And then maybe we can get into simplifying some of the statistics too here.
Yeah, sure. Yeah. Well, first of all, when you look at the we're used to looking at p-values, which is significant. So like 0.00001 is a very statistically significant number. When you use a systematic comparison like this, we don't look at p-values, and so we've got to get that out of our mind. So the number, there's a value called R that you'll see in the analysis, and the closer that number is to 1, that means that the more clinically comparable it is to Humphrey Visual Field Analyzer. So if a metric was 1.0, means that for that measure, it's as good. It's exactly the same as a Humphrey Visual Field Analyzer.
Perfect correlation.
Yeah, perfect correlation. 1.1 is better. 0.5 is not better, right? It's less. And so what I want you to understand is none of these met 1. None of them were better than a Humphrey, right? And if you look at statistically, anything over 0.9 means it's comparable. There's always some waggling data. So if you're at 0.9 or better, good. Less than 0.9, the lower down the scale you go, the less good or less comparable it becomes. So I think that's another interesting thing about this study that we've got to look at. because it's different than the way we're used to looking at drug studies, for instance.
Sure. Well, and with that in mind, what would you lead into there?
Well, again, if you look at the paper, there's all kinds of different values, but there's for what we're looking at, and this I'm going to nerd out a little bit, Dr. Christenson.
Yeah,
So
I love it.
forgive me on this one, but there's four really good markers that we can use for what we want to achieve in looking at this. If we want to make a decision as to a device is better than another, or a device is as good or a lot worse than Humphrey's. And the first one really is the ICC value in this study. The ICC is the intra-class correlation, and that's kind of the money metric in all this. To boil it all down, it's really, does the device trend the same way as a Humphrey Field Analyzer? So if I was to do the same patient on a Humphrey Visual Field Analyzer and a virtual reality device, the higher this ICC score is, the more comparable they become. That's kind of it crosses all borders, right? It's kind of like the rainbow coalition of statistics. It doesn't look at anything. It allows us to treat these devices equal, and it's really the strongest indicator of clinical reliability, which again, as practicing doctors, that's what we want. And it's without an ICC. And if you look at this study, some of these studies that they referenced did not look at ICC. And if you don't have an ICC, you really can't compare it. It can't be clinically interchangeable with a Humphrey Field Analyzer without ICC. So the ICC again is like the money metric here that allows us to say that this is as close or not very close at all to the Humphrey Field Analyzer on a global look, right?
Yep.
So that's again, the ICC is more of a global measure, but there's some measurements that are really important on the glaucoma side that we have to consider too, and one is the slope. Slope statistically in glaucoma, at least, is a basic measurement of regression or how bad is this condition. And I don't mean clinical regression. I mean, like, is this mild? Is this moderate or severe? Is how deep is the defect? Okay, that's basically what we're looking at with the slope, and it estimates the severity of the defect. Okay, not necessarily the disease itself, but of this specific defect in this specific patient. The slope estimates that, and so that's more of a that's more specific to the defect itself, right?
Okay.
And so the higher the slope number is, 0.9 and above, the more it correlates to a Humphrey Field Analyzer clinically, right? Now I'm going to break the slope down even more, and I'm starting to sweat. I get so excited about this stuff, but um, you know, as part of the slope, as part of the defect depth measurements, you want to look at global measurements, which is what we would consider to be like the mean deviation or the mean sensitivity on our traditional visual field printout, right? Those are global measurements. But you also want to look at the pattern standard deviation defects, right? That's more specific. That's a very specific to the focal defects, and we get hung up on that a lot with glaucoma, sometimes almost too much. But those were measured in almost all these studies, the mean deviation and the PSD. And again, the higher the number, the 0.9 and above, means better correlation to the Humphrey for our clinical purposes. The challenge here is that the pattern standard deviation is much more profound in later stage glaucoma than it is in early stage glaucoma. So a weak pattern standard deviation number, so meaning like an R value for the PSD of 0.5, basically is telling me that device is more likely to miss early disease.
Okay.
And the interesting thing about this study, a lot of these devices did really good in moderate and severe glaucoma, but a number of them didn't do so good in mild glaucoma, in early stage glaucoma. And from my opinion, for most optometrists, that's where the biggest decision lies. Does the patient have glaucoma or not? And do I need to treat this patient or not? So,
Yep.
so for our purposes, and general ophthalmology as well, who are not dealing with the decision whether to go to surgery or not, it's basically whether we should treat this patient or not. You know, a high PSD value on this study indicates that, gosh, this device, I can count on this device for helping me to make that decision in early stage of disease, and that's super important for most optometrists who are treating glaucoma.
Sure. Well, so I have one theoretical question for
Uh
you,
huh.
which is you can imagine, let's say we had a device that was actually superior to the Humphrey visual field, and how, when analyzing the correlation to that visual field, might that end up stacking out? Would we actually be able to tell that it was superior, or would we only be able to tell that it was different?
No, I think it would be if you put it through the same rigors. A number of a 1.2 value would mean that it's 20% 20% better than the HFA, whereas a zero point 0.8 value means it's relatively 20% not
Sure.
as good as the HFA. So I think
Sure.
as long as you can apply the same metrics and the same rigors, yes, you can make that decision.
You could be able to decipher that. And then secondarily, so you mentioned that these devices sounds like kind of across the board did better with the more advanced and even moderate glaucomas. What does that mean for utilizing a device like this for early detection, and how do you grapple with that, maybe in your
Yeah,
clinic?
it means a lot. And the reason it did better, the reason that most of these did better in late stage disease and early stage diseases is the dynamic range of luminance, basically of because it's using the same step thresholding type of. Most of these are using a thresholding type of delivery for the stimulus, right? Just like Humphrey Field Analyzer would. Um, but because of the headset design itself, it limits the dynamic range of what can be presented. The
Sure.
dimness and the brightness. In a bowl primer, you've got pretty much unlimited type of luminance you can deliver. When you go to a headset, it just limits the ability. Technologically, it just you're limited in what you do. So that dynamic range is sometimes limited, and that's a really important question if you're a doctor considering these devices. Look up what the dynamic range is. Ask the sales rep what the dynamic range is, and ask for the ask for the paper that shows what the dynamic range is, because if it's too narrow, the early disease will be underestimated.
Well, and
And
this is
that
certainly a technology that they're looking to expand what's allowable in multiple devices, whether it be a TV or a headset, right?
right,
You look at if you're perusing for what TV to buy, a lot of times they'll talk about the deep blacks that can be created by a
yeah,
micro OLED or something like that.
right.
And certainly that's technology that's becoming more commonplace in the newer versions of these headsets, which aren't maybe yet being used clinically. Is that fair to say?
That's a very great comparison. Yes, sir. Absolutely. And again, because of the design of the headsets, that's what limits the ability to go to the
It's a
lower.
hardware, it's not a software problem.
Exactly right. And so that's another thing to ask. And I think that's really important, because even if the ICC is good, let's say both you have two devices that have an ICC of 0.93, all right, which would be really good. If one has a wider dynamic range and the other has a narrower, choose one that has a wider dynamic range, because that's going to allow you to get to be more specific and sensitive at the early stages of glaucoma, which is where we want to do it. So to answer, that's a long-winded way of answering your question. We've got to look at it that way.
Yeah,
So if it's a narrow range of a narrow dynamic range, I would say there's probably other ones that are better to buy for our purposes. If
sure.
you're a surgeon who's worrying about whether they're going blind or not, the dynamic range doesn't matter. It simply becomes the slope and the defect depth. And then,
I think that's an important kernel for sure.
yeah, there's one other thing, one other metric that I think is super important, and that's the test time. And
Yep.
if you look at that, it's super important, because these all purport to be quicker, and they're not all the same. Some of them are 4-minute binocular tests, some of them are 8-minute binocular tests. And so that's another important question to ask, and ask very directly. For a 24-2 threshold visual test that I want to run on a glaucoma patient, how long will it take to get a reliable test done? And
Yep.
it's going to be anywhere between 4 and 6 minutes probably.
Sure. Well, and so logistically, that obviously poses some potential benefits or detriments, depending on how you're looking at it.
Yep.
What other maybe operational benefits do you think VR as a technology in perimetry can bring to a practice when we look at accessibility, we look at cost, patient experience? What stands out to you, and what stands out in the review?
Well, the review didn't really didn't suggest much there, but I can tell you, from having incorporated these into my practice, there's in my mind there's it, optometrists tend to have smaller offices than we need for some reason, so space is at a premium in a lot of offices. And so, these are definitely space savers. You don't have a big box. You can do it in an exam room. You can do it on a hallway if you wanted to. They're very relative. They're rather user friendly because there's a nice voice talking to you, and so patients tend to like it better than having to lean over into a big box and do an 8-minute test, and have a patch move over. And so there's no patching involved with this. The occlusion happens, surreptitiously and automatically in these devices. I think another huge advantage that I think with these virtual reality visual field devices is that, we tend to perhaps not have the best trained staff, or we don't take the time to train our staff to become really good perimetrists. And the data you get is only as good as the data that you put, the data put is input has to equal output. And so a lot of times these visual field tests, these traditional visual field tests, are prone to high fixation losses, or prone to, high false positives, false negatives, because no one's actually there sitting and watching and coaching the patient through it. Right. So this device does that for you. There's the magic voice in these devices will tell you if if the patient's not looking in the right place. It'll stop the test and say, please look at the yellow light or green light or whatever they have. It'll also give the really good positive and negative feedback to the patients. So the reliability should be better. And I think that's another really good advantage for us, especially if we have that one tech instead of 5 techs.
Sure, sure. Well, and I think hopefully, we're Eye.Talk.Tech. I hope our listeners will enjoy the technical, scientific discussion. I certainly do. But if I was going to pin you down a little bit in taking all this information in, what would you say stands out to you in this space in terms of being appealing based on what we know about what the review is telling us on the data here?
Well, I think this is what I will tell you. I think these devices are some of these devices are ready for prime time. I think we can. I think if you ask the right questions, doctors, you're going to be and you'll make a better decision as to which of these to buy. And I think you can be confident if you ask the right questions that these devices can handle the rigors that you need. I think the results that you get from these will be reliable, probably more reliable, because the test time is quicker, and it's a gentler test to take. Um, and I think if it's reliable, then it can be dependable. And I think it's also very, very repeatable. Another thing I think is really important is that, we're in the mindset of we can do a visual field once a year, and we can get paid for a visual field once a year. The Because these devices are, kinder to have done, and because they're quicker to have done, I really think it allows us to do more of these visual fields over a year. We're moving to an era in the glaucoma meetings now. They're talking about cluster visual field testing, where you get three in the first month, or 3 in the first week, or 3 in the first day, and then you get 3 more 6 months from now. And you've got this cluster of data, and if there's not, and it allows the progression analysis to kick in quicker, but also you get this big volume of data. Well, imagine trying to get 3 Humphrey Visual Field tests on the same day on the patient. That's not a great practice builder. So I do think this is going to allow us to get that volume of testing done quicker, so the progression analysis can kick in, so we can allow our clinical algorithms then to kind of move forward. Because when you look at all the literature now around visual fields and glaucoma, more is better for sure. And so I think this is going to allow us to get more data, as long as the device we're using is correlative to what we've been using in the past.
Sure. So I think it's helpful walking through a review like this, and I'm also curious what your firsthand experience is like, and what implementing devices like this into your clinical workflow has been like personally.
Well, first of all, you've invited a skeptic to your program today, so
You
I'm
took
a
some winning over.
well, yeah, I did. I'm a skeptic on most technologies, on most new technologies, and I believe in the devices I had before. I've had for 25 years, and I believe in the data that it provides me. So it took me a while to realize that, hey, there is something, there's some there, on
Sure.
these machines, right? Um, the interesting thing to me is when we first started employing these in our office, uh, the patients were skeptical as well. Because they, especially the veterans that have been doing all these visual fields, they would look at this device and invariably they ask the question, did Dr. Schmidt, does Dr. Schmidt know you're going to do this, or did what Dr. Walters approve this to be done today? Because they want to know that it's okay to do this.
Yep.
And that's what's interesting to me, because it's not just me that's the skeptic. The patients are skeptics too. So you may meet a little bit of that. I think that there's a bit of a learning curve, just like when you first do a visual field test on a patient for the first time. It's usually kind of a junk test, right? It's just kind of it's almost like a scrimmage game instead of a real game. So this does take a little bit of coaching, because it's different to them. Some of these devices, instead of a handset that you click, you can just you can they'll with the eye tracking they have, they can just it's gaze tracking, so they'll have you look
Mm,
at the so instead of using the button, they'll just monitor. They'll say, look at the light as it presents, and so it'll that's a good way to do it too. But that's different than what we've told them. We've told them, don't look at the light, look straight ahead of the fixation point. So it's different, but once you get over the different, it becomes like any new technology. It's like if you get a new OCT that's different than the one you had. It's different, right? But that different then becomes the new norm in your life. And the other thing is, I think you've got to figure out like where you're going to do this, right? If you have this device, you don't want to put it on a patient in the waiting room, right? That's a recipe for disaster. But you also don't necessarily need a dedicated room. It's also real easy for the techs, as they're working up the patient, to put this device on. If you know they're going to have a visual field done that day, put the device on in the exam room while the patients and do the test while the tech is inputting some more data. The efficiency factor is really, really, really important. And if I
sure.
may say one more thing, I was talking about the pre-testing. Some of these devices are not just visual field devices. Some of them are pre-testing devices. For instance, the Hero device has EOMs, pupils, color vision, um, confrontation visual fields, and they're all you can watch them on the device and make sure so the patients are actually doing it right. They'll also record. A lot of these will record, for instance, the pupil testing. So imagine you have a computer checking the pupil and telling you, yeah, this is the mesopic pupil is 4.4 millimeters, and the photopic pupil is 2.4 millimeters. That's a little bit better than if I'm saying, yeah, that's right. It's bigger there and it's smaller here, right? So,
Yep.
so it adds some quantifiable data, and so I think what the ability to incorporate to use these things in the pre-test area of your clinic is also a huge advantage that these provide, and those tests have also been rigorously vetted also, and so
Sure.
it adds to the efficiency of your practice for sure.
Well, I'm glad you stated that. I think that goes maybe underappreciated. We think of this technology for perimetry specifically is the commonplace arena, but yeah, pre-testing would be a huge boon there for
Yeah,
sure.
yeah.
And if you're going to speculate, if you're going to look ahead, it's cool. You said that these are ready for the prime time. Now are some of these VR devices. Where do you believe this will really make a big impact in the next 3 to 5 years? Maybe do you have
That's
a
a
sense of
good
that?
question. Yeah, so I don't want to reiterate. I said some of these devices are ready for
Yeah,
prime.
yeah, yeah, yeah.
So,
Fair
some
enough.
are not. Yeah. I just think, look, as we have to get busier in our practice, right? We have to see more patients, because our reimbursement is going down on all the vision plans, and we got a little bump in Medicare, but it's not going to keep up with the bump we have to pay our technicians and our staff. So we have to get more efficient, and this brings a lot of efficiencies to our office. I do think that there will come a time in the near future where you put this device on and it'll check visual acuity for you. It'll check EOMs, it will check pupils, it will do stereo, it will do color vision testing, it will do confrontation visual fields. And I would believe we're a few years away from where you can get an auto refraction on it. And so the tech can be doing his or her thing with the computer. The patient's getting all this information, which is should be automatically downloaded into your EHR system, would be the hope. You take this device off, patient's ready for the doctor. The doctor walks in, does his or her thing for 5-10 minutes, and can be very confident in the data that it provides. And I think that's where we're going. I think this is. I don't want to. I don't want to. I kind of look at it as a tech in a bottle. It's not a tech in a bottle, because the techs are so valuable for us. But I think it's going to free the techs up to do a lot of other things that currently the doctors are doing, which will allow the doctors to do more of what the doctors should be doing to more patients per day.
Yeah, which is interpreting all this data, right?
Yep,
And
that's
making sense of
exactly.
it and connecting with our patients. Yeah, I think that's a great vision for the future here, Dr. Schmidt. This really has been an incredibly insightful breakdown. I appreciate you getting into some of the minutia and also making it practical here too. But if you had one, final piece of advice for our colleagues that are looking at this space, what would you ask them to take away here?
Well, I would just say ask better questions about these things. There's certain questions, do they have gaze tracking? That's super important. What the testing strategy is, the dynamic range, the test time. So ask better questions, but also be very consistent with the questions you ask across the board. And I think you need to ask the same, put all these devices through the same rigorous questions. And so just ask better questions, do a better job of being a skeptic, do some research on your own. I think this paper will help a lot. But that would be my advice. Just that they're here, right? And they're not going away. They're going to get better over time. So just do your research and ask better questions about them.
Sure. Well, to our listeners, you can find a link to the systematic review paper that we've been referencing here, evaluating the clinical validity of commercially available virtual reality headsets for visual field testing. We got to work on an acronym for that, I think.
That's right.
We'll have that in the show notes. And if you found this conversation valuable, please like, subscribe, and share it with your colleagues. And Dr. Schmidt, thanks again for joining us here today.
My pleasure. Thanks for the invitation.